In the early 9th century, in the heart of Baghdad, the Islamic world was experiencing a quiet revolution, not of armies, but of numbers, instruments, and ideas. This was the age of the Abbasid Caliphate, ruled by al-Ma'mun, a caliph unlike most rulers before him. Al-Ma'mun believed that power did not only come from the sword, but from knowledge itself. Under his reign, Baghdad became the intellectual capital of the world. At the center of this transformation stood three brothers, Muḥammad, Aḥmad, and al-Ḥasan, known collectively as the Banū Shākir. Their story begins not with privilege, but with loss. Their father, Shākir, was a military officer who died when they were young. Orphaned, the brothers were taken under the personal patronage of al-Ma'mun himself, a rare and extraordinary act. The caliph ensured they received the finest education available in the empire. They were trained at the legendary House of Wisdom, where Greek, Persian, and Indian knowledge converged. But the Banū Shākir did not simply preserve knowledge. They advanced it. While others translated ancient texts, the brothers focused on precision science, astronomy, mechanics, and advanced mathematics. At a time when the Earth's size was still debated, the Banū Shākir participated in one of history's most ambitious scientific projects, the measurement of the Earth itself. Under al-Ma'mun's orders, scientific teams were sent into the deserts of Mesopotamia and Syria. Using astronomical observations and geometric methods, the brothers helped calculate the length of a degree of latitude, an early attempt to determine Earth's circumference with mathematical rigor. This was not theory. This was field science conducted under the open sky. The Banū Shākir also authored Kitab al-Hiyal, the Book of Ingenious Devices. In it, they described over 100 mechanical inventions, self-regulating fountains, automatic valves, feedback-controlled lamps, and trick vessels that behaved in ways that seemed magical. But these were not toys. They were early examples of systems engineering, devices governed by pressure, balance, and mathematical ratios. Concepts that would not fully reappear in Europe until centuries later. What made the Banū Shākir unique was their insistence on accuracy. They criticized earlier Greek astronomers when measurements did not align with observation. They refined Ptolemaic models. They corrected tables. They demanded repeatable results. In an age without telescopes, they achieved astonishing precision using instruments they designed themselves. Their influence extended beyond their own work. The brothers were known to fund other scholars, sponsor translations, and even commission experiments. They supported figures like Thabit ibn Qurra, ensuring that mathematics and astronomy continued to evolve rather than stagnate. Yet despite their impact, the Banū Shākir faded from popular memory. Their names were eclipsed by later giants, their machines dismantled, their manuscripts scattered. But their legacy remains embedded in the foundations of scientific thinking, measurement over myth, experiment over assumption, mathematics over speculation. They lived in a time when science was state-sponsored, when rulers funded observatories, and when curiosity was rewarded. The Banū Shākir were not merely scholars. They were architects of a scientific method, long before the modern world gave it a name.